Saturn's largest moon, Titan, has a thick atmosphere and a frozen surface rich in organic molecules. In 2034, a NASA mission called Dragonfly will arrive at Titan and study its chemical makeup. Dragonfly is a rotorcraft designed to visit multiple sites across the moon's varied terrain. At each new landing site on Titan's surface, Dragonfly uses a pulsed neutron generator and onboard gamma-ray sensor to detect key elements such as carbon and hydrogen in organic materials or oxygen in water ice. Dragonfly determines if there are well-defined layers of these materials just below the lander. For a closer inspection, Dragonfly uses its drill to generate tailings from Titan's hard, frozen surface. These surface samples can then be ingested through the pneumatic system, carried with Titan air into the chilled sample lines and to the sample collection carousel. One of the carousel sample cups is placed in a pneumatic port. The cup captures the surface material from the cold air stream and transfers it to the chemical laboratory for measurement. Pulses from a laser release large organic molecules from the surface sample for analysis in the mass spectrometer. The mass spectrometer sorts molecules by mass and measures diagnostic fragments that tell Dragonfly the kinds of chemical components that are present in the surface and whether there are molecules of prebiotic interest. For those potential prebiotic samples, a new cup is placed into an oven and heated to release molecules into a gas chromatograph, where they are sorted for size and type before entering the mass spectrometer. This advanced separation of organic components includes isolating molecules with the same formula but different chiral arrangements, or handedness. Having a preference for one-handedness over another is a key biosignature for life on Earth. When the chemical analysis is complete, Dragonfly may choose to take another surface sample or find a new location on Titan to investigate.